How many students have blonde hair and blue eyes? Let's just start there. Read the table. Blonde hair, blue eyes, see where they intersect. Blonde hair, blue eyes, I have 4 students. Yep. I don't want to go by too fast. Are we okay? How many had red hair? Now we're talking just red hair. So now I just got to look in the red hair column, and there's how many total that have red hair? 4. Probably stealing souls too. All right. 2 March. Sorry if I enter any gingers out there. Okay. Stealing souls. All right, everyone good so far? Probability the student has green eyes. Probability now. So we're talking chance that the student has green eyes. Well, how many students, according to this table, have green eyes? 5, but now since we're talking probability, you got to tell me 5 out of how many students here? 20 total students. Everyone okay? And if you want to reduce it down to 1/4, you can, that's fine. If you want to tell me it's 25%, that's fine too. All right, student has black hair now. A probability the student has black hair. So black hair, 9 students out of what we said before, 20 total. And I don't think you can reduce that, so we keep it 9 out of 20. All right, now we're going to get more specific. All right, here's where it may be a little bit trouble. Like you guys have been on easy street, so we're parts A, B, C, and D right now. Here's where you may have a little trouble now. If the student has brown eyes, so it's given they have brown eyes, so we need to focus on right here only. Brown eyes only. We cannot look at all 20 students. All 20 students do not have brown eyes. Only how many of them do? 7. So if the student has brown eyes, what's the probability she has black hair? So out of those students who have brown eyes, how many have black hair? 5, but now it's not going to be out of 20 anymore because we're only looking at the people who have brown eyes. So 5 out of 7. Do we see the difference between that one and C and D? Okay, C and D, we were talking about all the students. On part E, now we're just the students who have brown eyes. All right, now let's even get more complicated. Say there's 360 students in the grade. What would you expect how many to have red hair? Well, just out of this sample right here, how many had red hair? 4 out of 20 students that were sampled had red hair. But we're not sampling 20, we're trying to predict out of what? 360, so where should my 360 go? Numerator or denominator? Denominator. All right, so red hair, 4 of them out of the 20 that were sampled. Okay, what about 360? What do we predict? There's the x on top. We solved these in the past. How do I solve that? Cross multiply, go ahead. 20x equals, well, that's a large one, huh? 1440? Yep. Guy's unbelievable. So out of the 360 students, how many are going to have red hair? About 72 we're predicting. Yep. What are the other characteristics that go along with the red-haired ones? Other than stealing souls? Oh, I haven't. Okay. Good story. All right, moving on. Okay. Another two-way table, but now this represents gender on top and going, not going to college on the side. So those are the 2 things we're testing right now. So based on this table, is it more likely if someone's going to college is female or someone who is female going to college? And you read that, that's going to be the same. No, it's not. Okay, someone going to college is female. They could be male. Someone who is female going to college. They could not be going to college. All right, so let's test this first one out. So someone going to college, I'm just going to put C. So college is female. So what do we already know? So what are we trying to find on here? Are we trying to find they're going to college or that they're female for this first one here? Someone going to college is female. What's already given to us? Someone going to, we're trying to find what's more likely, that they go to college is female. So what are we already given here? This is where it's tough. The wording is tough. I absolutely agree. Because I want to know where to look here. Like, am I going to be looking at the female column for this one, or am I going to look at the going to college column for this one? So I want to find someone going to college is female. So where am I going to look now? I'm going to look at the going to college. How many total are there? 29. How many are female? So this one right here is a 13 out of 29 chance. And then the other one, female going to college. Now, which one do I want to look at? Now I'm going to look under female right here. This, how many are total there for female? Total for female, 22 now. And then how many are going to college? 13. All right, which is more likely now? 13 out of 29 or 13 out of 22? This one right here is about, I always look at the percents. It's about 0.45. And this one right here comes out to be about 0.59 in your calculator. So better, more likely, female is going to college. Yep. Okay, female going to college. Probability that a male will not go to college. A male will not go to college. So what column are we looking under here? That a male will not go to college. Which column are we going to look under here? Male or not going to college? What's the probability that a male will not go to college? Hannah? I'm looking under male, yep. So how many males are there? 30 males, right? And out of the 30, how many are not going to college? 14. So if you want to reduce that, go right ahead. And if not, we can leave it 14 out of 30. All right, 208 kids in the graduating class. How many of them would we expect to go to college? How many are going to college right now out of this sample? Out of this sample, how many are going to college? 29 out of 52 students. Yep, it says students. Doesn't say break it down by gender at all. So I go total students, 29 out of 52 are going to college. Now I'm looking for, well, what if there's 208? So where should I put the 208? In the denominator? X. And we end up with about what? 116 students we predict going to college. Yes?
How come you wouldn't put that on the top? Or no, wait, never mind, I get it.
Okay. Anybody else? All right, we only got a couple more here, then I think we're going to go regions here. All right, so again, gender on the side. Now we have likes, math, English, social studies, science. Okay. Here we go. Find the probability of being male. Ready? Male. Probability of being male. So those are all the males who like social studies. How many males do I have? 26 males. How many like social studies? 8. And as a decimal, 8 out of 26. What? You all right? 8 out of 26? I know, but it's in decimal form, so. Okay.
No.
I just said 8 out of 26, and I just want to know the decimal form. Sorry. Okay. Probability of liking math. Any gender given? Okay, so how many like math? 18 out of 56. No gender, I go the full student body. I guess I could say yes right there. Percent of females who like English. Percent of females. So now I'm going to start asking you guys here, what out of what? What percent of now females, we're looking at females, what percent like English as their favorite subject? All right, so here we go. I don't know why that's on 100. What should your fraction look like before I calculate the percent? 4, what should my fraction look like here? 6 females like English out of 30 total females, yep. And as a percent, Sam, what's that give me? 20%, yep. All right, one of these more likely questions. I know we love these. What's more likely? Social studies will be female. Or a female likes social studies. What's more likely? All right, so this first one, they like social studies already. They like social studies already. So how many total people like social studies? 19, and how many of them are female that like social studies? 11 out of 19. They're already female. How many females do I have? 30 females, and out of those 30, how many like social studies? 11, all right, so what's more likely, 11 out of 19 or 11 out of 30? 11 out of 19 is 58%, about, and 11 out of 30 is about 37%. So more likely, you like social studies, a person who likes social studies will be female. Yep. And I'm going to let you do exercise 4 on your own right now. See if you can do this on your own. I'll call on 2 people here. It's pretty clear what's given. So the first one, given the person rides a train to work. So find out how many there are who rides a train. And then out of them, what's the probability that they live in New York? Number 33 on the Regents. Again, with the unit we're in, we should be all right. Look at everyone typing like they're texting into their calculators. Take your time. You got decimals here. Take your time, guys. Take your time. There's 9 values, so make sure we got 9 in your list. Look them over before you calculate anything. Always, never 8. We never touch 8. Okay. Equation. Just give me the equation first that we got. Equation. Here you go. 15 equation. Oh, hold on. We got the x in the wrong place here. Yeah, I have an a value though of 17.
No, you
Make-
typed it right. You just have the numbers switched.
Oh, 7, yeah.
So 17.159x minus 2.47. I have 6.
Yeah.
6. Okay. If you're not getting that, make sure you're going to number 4 on Stat Calculate. And if you're still not getting it, make sure the numbers are typed in right. Okay, if you're not getting these values. All right, now using this equation, what's the slope of the beach with a diameter of 0.65 millimeters? So what am I doing with that 0.65? Help me out. 11, help me out. No 11 today? What do I do with that 0.65? Yep. And round it to the nearest tenth of a degree, minus. What's the slope of the beach? You all right there?
Y equals 8.7.
Yep, 8.7 degrees. Anything else there? We all good? Get your stats homework back out. Go ahead. You can start your stats homework. You guys that are watching this, we also went over 26. You can pause it if you need to. And we also went over 25. Making sure we made a table for the graph, using only whole numbers for the table. You can pause it here if you need to. And then here was exercise 4. Not sure if that got onto the video as well from your stats packet.